Hello and welcome to the Software Engineering Unlocked podcast. I'm your host, Dr. Michaela, and today I have the pleasure to talk to Derrick Stolee. Derrick is a principal software engineer at Microsoft and works on Azure DevOps. He also contributes to Git. Prior to joining Microsoft, Derrick was a professor for mathematics. If that's not intriguing, I'm super thrilled to hear from his experience switching careers and working on such a popular open source system. So thank you, Derrick, for being on my show.
Thank you for having me.
So Derrick, let's start from the beginning. How comes that you as a former professor are now working for Microsoft as a principal software engineer?
Yeah, I think it's an interesting story in the sense that I originally wanted to be a programmer. That's what I went to college for. And so I did a lot of software engineering and programming courses in undergrad, but I also kind of fell in love with math and advanced math at that same point, in which inspired me to say, you know what, I don't want to go into programming right now, at least. I could maybe fall back to it later if this academic career doesn't work out. And so I went to grad school and I did postdoc and I got a faculty position, which was the dream, right? You know, it's so hard to get to that point. And I had a lot of luck getting there. But then after I was there, I was realizing that being a faculty isn't as fun as being a grad student. There's a lot more responsibility, a lot more meetings, and just the schedule wasn't quite fitting in with what I wanted to do, which is I wanted to solve cool problems. I wanted to write code to help me solve those problems. And that was becoming less and less a part of my daily life. So I was sharing with my spouse that, you know what, maybe this isn't the right career for me. Maybe I should look into doing something else or drastically changing how I'm doing the career. And she decided that she could also maybe decide that she wanted to be in a different institution. So she went on the job market and found a job here in Raleigh at North Carolina State. And so I said, yeah, let's go for it. And I agreed to move out here without even knowing if I'd have a job. And I was expecting to kind of need to knock on a lot of doors. But I found out that there was a small group here where Azure DevOps is built here in the Research Triangle. And they happened to need somebody to do some sort of graph-related problems. And I had experience with graph theory, and that fit in really nicely. So they took a risk on me because I wasn't really experienced in building software in a team in a professional environment. But I really think that it paid off because I was able to build some really cool stuff here.
Yeah, that sounds really cool. So that was also coming to my mind. If you are a professor for mathematics, you're probably not at the same time a sophisticated programmer. But you said that you already built stuff and used code to solve some of your problems at university as well?
Yeah, my research area was, I called it computational graph theory or computational combinatorics. So I would look at a math problem and figure out if I could solve it using computers as being my proof technique, or at least to help me discover things that will lead to deeper proof techniques. So while the end result was about super theoretical problems, I was writing a lot of code, but I was doing it by myself. So when I actually started working on a team, you know, I was hired for my expertise, which was mature and had a lot of deep knowledge, but also just how to work on a team. I was making a lot of junior mistakes, you know, checking in to master at 5 p.m. and going home without realizing I hadn't run the test suite. You know, those sorts of mistakes kind of happen and you learn how to fix them. But that was definitely a learning curve in terms of how to interact with a team, how to do code review, how to work with the release cycle, manage live site stuff. None of those things had I been prepared for. But, you know, going to grad school kind of, you know, being very educable, right? Being able to learn new things is kind of what I've been trying to do for many years. So hopefully that translated into I can pick this sort of stuff up very quickly.
So when you went into the interview, how did you approach that? Did you say, I'm actually not that experienced with development, or I can learn on the job? Or how was that? How did you communicate that?
I started out being very humble, you know, trying to just lead with, you know, I'm really excited about writing code. I definitely, you know, I'm switching careers and I understand that I'm not going to be doing the same things. And I have a lot to learn, but I'm really excited about it. Some of the technologies, you know, C# and .NET, I was familiar with from really early days, but I knew I was going to have to learn a lot on the job, and so I was very open about that during the interview cycle, talk to everyone. It's like, yeah, I'm not expecting to just be able to do research-like things anymore. I'm expecting to contribute. In fact, one person very early in the loop says, before every major release, everybody gets together and we spend a day during a thing called bug bashing, where we just try to break the product and we report a bunch of bugs. Is that something you're willing to do? And I said, yes, absolutely. I want to be a good citizen and contribute to the team. And I get the feeling that that's not the answer they always get from people with PhDs and research backgrounds.
Yeah. So I think also in my experience, I see that there is some, how to put it, maybe, some reluctance of researchers to actually do the daily work of developing software. And so I think it's just fair to ask whether or not that's actually something you're committed to and whether that's something that you would want to do.
Right.
But now that you program on a daily basis, do you think that the work that you did prior to that, so the work you did as theoretical mathematicians, shaped your mindset as an engineer, and does it influence how you approach problems?
I think it does, especially when I'm trying to. Sometimes I'm able to say, here's a really deep algorithm insight, and here's a connection to something that's actually math, but it's not super important that you understand the math. It's, do you understand that it's working correctly, and how do I prove that to my peers? Or how do I break down a problem into pieces? That's also one of the biggest things to be able to do research mathematics is, I want to prove this big theorem, which is like the big result. But in order to get there, you have to prove a lot of smaller pieces called lemmas that then combine together in an interesting way to create the full argument. Like that breakdown into kind of components is very important to be able to isolate how much logic you have to keep in your mind at one time. But then also there's the idea was that after you prove a big theorem, you try to look for things that can be easily proven after that, and you get your corollaries. And in software, I think that's really important. You want to, as you're building to this big finish, have these smaller components that are reusable, are testable, and can be delivered in a small commit. But then they build to that large piece. But then once you build this large piece, is that the end game, or is there something else you can do? Is there, now that I have this, can something else fall out of that?
And so can you tell me a little bit about your interview experience? What do people ask a former professor during an interview? Did you experience a typical interview process with whiteboarding, coding exercises, or what are people expecting from you?
Yeah, the interview process has updated a little bit since the 4 years ago where I interviewed, but there's some similarity. And I remember the first part being over the phone, via computer chat, where I was given a programming problem and I was supposed to share my screen and do a text editor to actually do the program. And I remember that the problem I was given was actually a homework I had assigned my C programming students a semester ago. And I even mentioned that, like, are you sure you want me to solve this problem? Because, it's probably not going to be hard for me. But they, went through it, and it was more about, can I explain the solution? And, if there was a twist at the end, like, okay, now that you've built it this way for the simple case, let's make it a little bit more complicated. And can you adapt to that change of requirements? I thought that was a very interesting way to take this, what could have been a simple problem, but turning on its head a little bit. And then when I got to the on-site interview, there were several of those. I think I met with 4 people. And I remember at the time I was interviewing, I talked to 3 principal engineers and 1 senior engineer. I was thinking, wow, there's a lot of principal engineers here. It just turns out, it seems like they were trying to figure out what seniority I should be coming in at because of my lack of experience. So they put their best people on to make sure what I knew. And again, it was a lot of the whiteboarding problem sorts of situation. Here's a problem, explain to me your solution, and actually try to write some pseudocode on the whiteboard. And even the whole time I was feeling it, I was like, I think I'm actually well qualified for this specific type of interview because I solve problems all the time. I did programming competitions in undergrad. So I feel like they weren't really necessarily getting to how good of a software engineer could I be. I felt like I was unfairly succeeding in those things. But then I got to my optional interview, the one at the very end was like, this is the person who's going to decide if I did badly at the other ones, they wouldn't even talk to me. That's usually a common thing. And when I got to that person, they mostly they were asking me the higher order questions. What has your biggest success been? How would you design a system to do something, as opposed to show me how you can write code? And so at that one, I actually then got very nervous.
Yeah.
In retrospect, I think I did okay. They hired me anyway, but I remember for a while thinking, why did they say yes after that interview? But it worked out.
So when you started working at Microsoft, what did you actually start working on? So what is your project that you are contributing to?
When I first started, I joined the team that builds what is now Azure repos and working on the Git server. And we have our own C# implementation of a Git server that is very focused to work in our architecture of Azure DevOps. And there were some scale problems we were running into because at that point we had not built it strong enough to withstand the Windows repository, which now the Windows OS repository is running in Git on Azure repos. And so that was kind of our North Star of we need to make this scale to that size. And at that point, we were using just the Azure DevOps code and some other internal customers, but we were definitely the largest repo at that point, and we were running into scale issues there. And the thing I was hired to do was to fix our commit history story. There was a really interesting design decision, mostly because this is all built, based on top of TFVC, our Team Foundation Version Control, was the same team who built that, started building the Git server. And Team Foundation Version Control is primarily run through SQL. SQL has all the data, and it's very centralized. So it's really easy to use SQL as this centralized source of truth. But then a lot of those architectural decisions transferred over to the Git server, including trying to use SQL for commit history. And it was a very impressive attempt, but they could never get it to match what Git log would output, and customers were complaining. And the biggest issue is that commit history in Git is a graph. It's a directed acyclic graph. It is not a linear history, and you need to be able to navigate that. And so after I did my first couple of months of getting used to the system and fixing a few small bugs and making sure I knew how to interact with my team, I moved into the working on that problem and deciding what is the solution there. And the solution we came about was to create a compressed commit graph that was focused on the structure between the commits. And once you start at one, you can walk the rest very quickly. And a lot of algorithms to make those walks be fast, but also just having a new file format. And it wasn't something you could do in SQL. You just have to make a new binary file and have a job that keeps it up to date. And that allowed us to do things like when you look at commit history in the web on Azure repos, you see it in topological order. That was kind of the thing that we knew was a differentiator. The command line has to explore every commit possible. And so even on our small repo, it took 7 seconds, but we could do it in 200 milliseconds. And that was kind of the start of being able to build these bigger and bigger features to get us to the Windows scale.
Okay, so maybe to give a little bit of context, this was actually the time when Windows tried to move over to Git and use Git as the source code repository and versioning system,
Yep.
right? And the problem they ran into was that Windows is too large to smoothly work with Git.
Yes.
So then your team was responsible to help out at that point.
Right.
And those tweaks that you describe plug into that larger effort of making Git work with Windows or Windows with Git. Is that correct?
Yeah, so I'm just talking about one small piece of a large system that is about that, and it was focused very much on in the cloud. How do the cloud servers stay running with so much data that they're processing? And because it's also that it grows, right? As people are interacting with it, there's the scale of 4,000 engineers are pushing and pulling and all that, but there's also just after a year they've got millions of commits, and what do we do with that? In parallel, other colleagues on my team were building what is now called VFS for Git, which is a tool kind of built around Git for the client-side experience and making that scale.
Yeah, the virtual file system, right?
Yeah, virtual file system for Git. It allows it, instead of needing to have every single file in your source directory actually be present, have Git manage all of that. It uses a file system driver to act like it has it all that. So it's kind of projecting what Git expects to be there. And so if you look at it in Explorer, it looks like all the folders are there. But as you start drilling down, we're dynamically populating that data as you go down. And that's how you can take this 3 million file repository at a single checkout. And really, you only need maybe 200,000 files out of there. You don't need to have all of them.
So are there other projects that you are aware of that are also benefiting from that? So is it something other larger repositories out there could use? Or is this really, really specific to Windows and the repository of Windows?
I think that there's a lot of things that are specific to Windows, but also, we're working currently with the Office team to get them moved over to Git, and they have very similar scale targets. But in terms of, those are the only two repos we've seen out in the wild that are big enough to really require that complicated system. And part of that is because in the process of making this client experience better, a lot of it's just you need to make Git better. Git is a very core part of this. Yes, we've added a lot of bells and whistles around it or integrated pieces into it, but those have actually gotten into the core product so that Git is actually so much faster and can handle what other repos are out there.
Okay, can you explain a little bit more to me how the work that you do at Git or Git for Windows or Git for Microsoft fits into the work of the open source project Git? How do those two projects connect and, well, where do they differ?
Yeah, so a couple years ago, I switched teams from the server side into the client side. And part of the goal was, I've got all these ideas and thoughts that we did and integrate into the server side. And it's like, I wanted to contribute those into the client and make the client faster. And I could see that we were going to have issues on the client side even on the Windows scale, because while VFS for Git had all these things to make the amount of data transfer be less and all these work directory things, I knew that as we grew, we were going to have some problems.
And this is now the Git client?
Yes. So moving over from the server side into the Git client, and the Git client has, I would say there's a few forks of it. So if you go to github.com/git/git, in the Git organization, the Git repo is the Git code that is maintained by the Git community, and it's reviewed. All code is being submitted through a mailing list and is being maintained by the one maintainer of Git who's been maintaining Git for many years. Then there's Git for Windows/Git, and the Git for Windows thing, which is a fork of Git that has a lot of extra things just to make sure it works on Windows properly, because Git was built for Unix machines. There's a lot of assumptions about that, and making that all work through a compatibility layer for Windows goes through that repo. And that's maintained by my colleague, Johannes Schindelin. He does a great job. And that's where, if you were to download Git for Windows, you would want to go there. While the Git/Git is mostly cross-platform, it's got the core version. You can install it onto Linux immediately. You can install on the Mac. You can even install on the Windows, which just might have a few rough edges. And then we have our Microsoft/Git fork. So in the Microsoft organization on GitHub, and that's where our team is running things on top of the Git for Windows patches, things that are specifically tied to VFS for Git. So there's some things that will never make upstream because they're really just, when we are in this particular environment, we need these patches. But sometimes we just take performance fixes a little bit faster there. But the intention is we want that fork to be as small as possible. So we are trying to send all of our performance enhancements to the main line, to the core Git project. So that way everyone who uses Git anywhere can benefit from these improvements.
Yeah, that actually means you're in a very interesting position. So you work for Microsoft, but not solely for projects that Microsoft owns or builds. But in contrast, you're working on an independent open source project, namely Git, and you help, enhance Git and change and develop this open source project. But it should go into a direction that is also beneficial for both, Microsoft and the open source community. This means that you have to constantly think about win-win situations and how every stakeholder benefits. How is that reflected in your daily work?
Yeah, it's really interesting when we had internal our team saying, what is our priority list? That's definitely motivated by what's our next scale target? What issues are our internal customers having? What sort of things do we need to get ahead of before they're a problem? But then we need to take those ideas and bring them and connect them to how is the community going to respond to these ideas? How can we make them as beneficial as possible for everyone? And so a great example is I took the idea of this commit graph that I had built for the server in the C# layer and said, we should have this in Git as well. Without it, these Windows developers are going to have a lot of difficulty working with the millions of commits they have. But also, let's take a look at, a regular size repo, like the Linux kernel repository, or just the Git code itself. The Git code has 38,000 commits, something around that line. That's very small compared to the Windows repository, but I was able to demonstrate, hey, if you use this commit graph file, even the Git repository will speed up. And, it goes from maybe 3/4 of a second to a quarter second, but that's enough to notice that a user ran a command and it either responds immediately or you had to have a pause and then it responds. Or in the Linux repo, it's something that took 10 seconds, now it takes 1 second. And having that mean that this is going to be a realistic improvement for a lot of engineers, a lot of people working in Git, that's what makes it worth the community's attention.
Yeah, one of the things I was thinking about, well, because on your Twitter profile you say you're making Git faster, was how you make such a mature and widely used project faster. And it seems that you're really talking about algorithmic changes to the underlying system. Is there something else you do to improve the performance of such an application?
Yeah, sometimes it's, let's make the code do less, right? We have this black box of the Git command should do X, and can we make it do X without actually doing as many operations? So is there just the algorithmic view is, can we just modify the order of which we're computing things? The other way is to say, can we do some sort of caching, where the commit graph is this thing that if you just run this one command, it'll build it, and now it's on disk, and now we don't have to do all these expensive parsing later. We've kind of pre-computed and saved that time in later things. So we're not actually changing how many commits we're inspecting. We're just making that inspection a lot faster. But then there's other things where it's like, maybe if we just change how Git works, like maybe it's doing something that it doesn't need to do. One example is in the status command. If you have a local branch and it's tracking an upstream branch in your remote, status will say, hey, your local branch doesn't agree with the remote. You are 100 commits behind and 8 commits ahead. So you can say, oh, I know that there's a difference here, but there's also that count. That count isn't always super helpful in the sense that, especially, say, the Windows repository where you wait a day and you're 10,000 commits behind. Does it matter that you're 100 commits behind or 10,000? But if you are 10,000, computing that exact count is really expensive. So, we modified that command to say, well, if you put in this config setting, it'll just say, you differ. I don't know by how much, but you don't have the same ref. So maybe you want to rectify that at some point. But it doesn't cost you every single time you run status, do this expensive computation for values you don't really need. But it is changing the behavior. The output is different.
Well, so now you're working for several years on that problem of improving the performance of Git. So I wonder, is there still room for improvement? Is there still opportunity for that? Or are you now looking into other areas?
There's absolutely ways to improve it. And, one of the big things we're trying to do that, it's been a kind of the whole community has been trying to figure out how to do it is that VFS for Git, one of the ways it works is we made a custom protocol that, is currently only implemented on Azure repos, and it doesn't use Git to do it. It's just, how can I transfer some amount of objects, but not the whole repository, right? If you do a Git clone, you get every single object that those commits can reach. And how can we make that so it's not so expensive? Maybe we don't need to do that. And the community with some Microsoft people and some Google people and other community people have built this idea called a partial clone, where you say, maybe I want to do a clone, but I don't want to have any of the blobs. I will ask for the blobs as I need them. That would be a dramatic improvement to clone because you don't have to have every version of every file in your repository. When you do a checkout, it'll say, oh, I don't have this blob. Let me go download it. And that is still being maturing in the community, I would say. It's one of those things where it's definitely the next big way to allow vanilla Git, just regular Git out of the box, to scale. But it requires not just the client improving, but the server experience improving, making sure that the way we're doing these problems can actually scale for that the services do not fall over when people are asking for all these blobs. And it just changes the way you work with Git so much that it needs to go slowly.
So, okay, when you say it needs to go slowly, what do you mean by that?
It goes slowly in the sense that we had to agree first on what does it mean to be a partial clone. Where do we draw the line? And then it's actually been implemented in the client that you could request a partial clone, and we're at the point where the services are still trying to figure out, how do we be able to serve partial clones at scale and actually be able to turn it on for clients. But if you actually just used Git itself to run an Apache web server, you could set up one that has partial clone. It's just might be a little slow. It might have some performance issues on the server side. And we're still trying to track down all these different places where Git isn't really good about handling that expectation of I want all my objects, because it's expecting them to all be there. And so there's all these usage patterns where it'd be better to ask for this set of objects in a big batch as opposed to asking for them one by one. And Git's still trying to figure out how to do that.
So if I imagine that people are listening in now and they are as excited about algorithms as I am, that they think, how can I contribute to such an interesting project? You also mentioned that Google and Microsoft are working on that project. So who are the other players that contribute to that open source project, and how can others, outsiders, have their say or be part of that open source project as well?
Yeah, so, in addition to people at Microsoft and Google, there's also our colleagues at GitLab, GitHub, and all the other places that kind of run Git as a server. And there's also just a lot of community members who they're just really passionate about Git, and they are very present on the mailing list, which is how we do all of our code review and all of our communication about where Git should go. You could find out most of that if you want to just look at what the history in the archive is. You go to public-inbox.org/Git. It has a list of all of our discussions, so it's out in the complete open. You can also join the mailing list, and there's some instructions on that inside of the README for Git. The thing that's interesting is that Git doesn't have a backlog. There's nothing where the maintainer says, this is the vision I have for Git, or these are the things we've accepted as being the place we want to go with Git. It's more reactionary to people come with ideas about, here's something I think Git could improve in, and here's something I'm passionate about. And that's usually how things get done. Somebody comes in and says, this feature doesn't work the way I want it to, or doesn't work as well. Let me go and try to do something to help. And then the community decides, is that something that is valuable?
And do you know what is the percentage of individual contributors versus contributors of larger organizations? Do you have an idea of the proportion?
I would say it's probably, I would guess half and half. I would say there's about half that are, that it's clearly their day job to work on this. And then half where it's just they are passionate. They work on evenings and weekends and are very vocal about, the things that they care about.
Yeah, that is quite an essential number. Actually, quite a few people are involved in that project, it seems.
And I'm sort of thinking about this in a weighted sense, because not everyone is contributing at the same rate. So there's definitely many more individual contributors in terms of just literal number, but again, because they can't spend all day every day thinking about it and contributing, that their rate of interaction on the list is smaller sometimes. There's also some individual contributors who contribute way more than even me, because even though it's my job to do that. So But I would say in terms of the volume on the mailing list, I would say it's half and half.
Okay, well, you mentioned already code reviews. So I want to know a little bit more about your engineering practices that you have. So you do apparently do code reviews. How do they work? And well, I know that Git actually is driven via a mailing list, like many open source projects.
Mm-hmm.
Can you explain a little bit about how to do code reviews via, well, a mailing list? How does that work?
Yeah, it's very interesting that, we use email, even though, we are building Git, but Git has ways of creating patches, email patches based on the commits. So it'll include your commit message, information about who wrote the commit and when, and then it essentially supplies the diff for that commit. And that's what you send up. Now you can group those patches into a thread of, a patch series, and include a cover letter. And that's usually how you would do it. And the cover letter can kind of justify, here's the full series of commits and what the whole series is trying to do. And that way, each individual patch can be self-contained, can be small enough for a human to digest it and review it on its own. And what happens is that the email thread starts to expand. People will reply to each individual patch saying, this part of the patch could be better, or here's a style issue you had. Maybe you could write it this way. Hey, I don't understand how this is going. Could you explain it better in your commit message? Sometimes it's, maybe you don't need both of these patches. Maybe you should combine them. Or this one's too big. Could you split it up? There's a lot of attention to detail, that's for sure. Way more than I've ever experienced on any other project. Because, Git is used by so many people that it's really important that it doesn't break. And it's built in C, which is doesn't have any memory management. It's very fast, but it isn't very forgiving to programmer mistakes. So having all of these things be meticulously looked over is really important. So that way we know that this change that we're making, one, is valuable, but also has low risk, as low risk as possible. Every change has some amount of risk, but can we find ways to minimize that? Or at least if we have risk, localize it to a place. Like maybe we hide it behind a config setting for now, and we'll move that config setting to be default later. Or maybe it's just when you have this particular feature, and then we'll expand its use later. How can we kind of limit that? And then also, do you test it enough? How deep do you want to go on your testing to make sure that this is going to be covered and not only works right now when you build it, but a year from now when people have built upon it or changed some of the underlying APIs. So maybe the things you're relying on don't work the same way. Is your feature going to be working correctly?
Yeah, testing is one of the things I wanted to ask you about. So is there some policy around testing? Do you have to submit tests with every batch that you submit, or how does that work?
It really depends. Git has, the overall opinion is that tests should, as whenever possible, be user-facing tests, in the sense that we're building a real repository and we're running a real Git command and expecting certain output. So it's not the typical unit testing you would expect. So
that's an end-to-end test.
Yeah, I would call it end-to-end test as much as possible. There's some limits in terms of, we don't always do big fetches across an HTTP connection. Sometimes we'll just do a fetch across your file system to kind of mimic that, but also demonstrate some other behavior. But it means the test suite is really a bunch of shell scripts that execute a bunch of Git commands. And so there's some limits in terms of how specific those tests can be. Can we actually get it to trigger this error condition or this assert statement? It's not always possible. One thing that I did, I think it was last year, because I realized that I had accidentally not tested something, or the test I had written wasn't actually hitting the code I thought it was hitting. There was some code in the makefile to run it with GCC with the right things to do coverage analysis. And you could run the test suite and see what had been covered or not. Now, if you run that on the Git code base, you're going to find a lot of lines are not covered. Partly because this philosophy that, we try to cover the main scenarios and some of the error scenarios. But what's valuable is to say, like, what has been contributed recently that hasn't been covered? Have people been writing new code without creating test cases? And so I started creating the test coverage report, which means that every few weeks I run this build and I run test coverage, and then I do the diff between what was master on 2 weeks ago and what is master on now. And of those lines in that diff, which lines are uncovered? So did you change something that wasn't covered before, or did you add a new line and you didn't produce a test case for it? And that's been really interesting to see, especially as that report's been coming out, how it's been getting smaller. People don't want to be in that report anymore. So people are being very careful to include better test cases and cover all these scenarios. And definitely in the year or so since we started doing this, people have, I think people have been seeing the test cases improve. I definitely have seen the reports get smaller. There are many fewer uncovered lines being introduced.
Yeah, so one of the questions I like to ask you is, are there some differences between how you develop software at Microsoft, so for the projects that are Microsoft internal or completely owned by Microsoft, and the Git mailing list? So do the engineering practices differ, and if so, in which ways?
I would say that, when you're working internally on a team, there's, essentially anything you're working on is sort of assumed that this is something that's on the backlog. Your team lead and your program manager have decided this is something important to do. And so as soon as you create a PR, everyone says, okay, you are working on this. You want feedback. I don't need to say, why is this important? Because there's some reason why it's important. And we just need to work on making that the best version it can be. While on the Git mailing list, every single time you submit code, you have to say, this is some justification for why I did this and why we should take it. No one else in the community has created a backlog that says, oh, look, just look here. We've had this on our list to do for a while and no one's gotten around to it. I'm getting around to it. I had this idea. I think it's helpful. Here are the benefits for users. Here are the benefits for people in the community. And the other thing about it is that usually the pull request is the unit of a review. I'm reviewing this pull request makes sense. Should I merge it or not? While in the mailing list, is each individual commit, each patch worthy? Is each patch perfect or as perfect as it can be? And being able to justify small changes with a paragraph of text is a skill that I have been working on and still working on, because it can be very difficult to actually take some change that needs to be big in order to make the end-to-end change you're going for, but then breaking it down into smaller pieces so that people can understand it, can digest it all at once. They don't have to just review 1,000 lines of code. They can, you can take that 1,000 lines of change, split it across 10 commits, and suddenly it's a little bit more digestible.
But so this means that there is no actual roadmap for the Git project. So that you can say, well, that's our roadmap. That's where we want to be in 2 years' time.
Right. That's, Junio, the maintainer, is very busy just taking in all the input. There's plenty of ideas coming in from the community that he's not reaching out for, hey, let's do this as well. It seems that he's much more about where do the community want to go. He doesn't want to dictate, this is where we're going. He just wants to respond to people's feelings and, what sort of situations are there that we need to resolve now. Very much believing.
And so can I imagine that it's decided in the moment? So I'm sending an email saying, well, I want to improve the performance of that piece, for example, and then it depends on the feedback that I get to this email. Mm-hmm. So let's say how many yays and nays do I get from the community decides whether or not this change actually happens or not, right?
Yeah, I guess there's, we can say things like, here's an idea I haven't even started building it. I'm looking for comments. Is this a good direction to go? And people can respond saying, yeah, I think that's a great idea. You should watch out for this. Here's why I didn't do that already, because it seems challenging in this way. Or you can, I frequently do is I quickly build something. I haven't perfected all the patches. And I say, I'm submitting an RFC, a request for comment, saying, here's a rough, outline of how we could build this. Do people think this is worth building? Do people see problems with my approach? Because before I go and start building all these test cases and really polishing and doing a bunch of deep perf work, is this even an idea that we want to think about? And sometimes people come back and say, no, this isn't actually what we want to do. Going this direction would be better, or, that's just not the way Git works. But sometimes it's, well, yeah, we've had this idea before. Here's the previous discussion even. People have found that in the archives, things from 10 years ago that I would have no reason to know that existed. And they can say, this is why we didn't do it then. Can you solve those problems now?
So this means that there is only one place, and that's the mailing list, and everything is discussed via this mailing list. And well, there is no other place like a board where you, for example, have issues or milestones that the community members can vote or comment or discuss on. It's really just the mailing list.
The philosophy I've heard is that if it didn't happen on the mailing list, it didn't happen. But there are other ways of communicating. We have an IRC channel, for instance. Occasionally, people put up different places where you could submit issues or things. Again, my colleague Johannes has made the submission process a lot easier. He built a tool called Git Gadget, and it's actually how I submit my patches to the mailing list. You go to github.com/git-gadget/git and open a pull request there. The Git community doesn't take pull requests, but you can create a pull request and then type /submit in your comment, and a bot will pick it up, convert those commits into emails, and then send them off to the mailing list for you. And it even handles versioning. Like if you update it and you say, okay, now I've changed my commits to respond to feedback, I push it again, it'll say, oh, here's patch series V2, and it's all nicely threaded. It shows a diff from your last one. It's really, really nice. And there he's been storing issues as well. Like here's an issue that is maybe something for a new contributor or could be helpful, but it's mostly because it's been discussed on the list. It's like, well, let me create an issue for it, and links to it on the mailing list saying, if no one's going to pick this up right now, I've archived it here as well for other people to look at and point to. But that's part of the decentralization of Git, is that while there's the mailing list is the central point for all of Git, there's all these little bifurcations of this sub-community talks about it over here, and this sub-community talks about it over here. But when they want to bring it into core Git, they talk it on the mailing list.
So the main decision power lies also in the mailing list and, well, the community there.
Right.
Well, one of the things I wanted to know is, you're talking about the Git Maintainer, and in general, maintainers of open source projects seem to have quite some authority over the decision-making process. So how much do you think, for example, the Git Maintainer has the final say in whether something is going to be implemented in Git or not?
Yeah, Junio Hamano is the maintainer, and he definitely does have the final say in terms of which commits get into the releases. I found that he's been very reasonable to take ideas that are out there and kind of defer to the community. And that's kind of the stance he has shown and also said explicitly that that's his mode is, what does the community want? I'm here to facilitate that, not to dictate from above, but to just be the central source of, maybe the final guard in terms of quality, but not necessarily, I don't want that. And because I don't want it, it's not in. It's, he'll sometimes voice an opinion. And if enough people say, what, this is really important, he will probably change his mind as opposed to just give in. But also, I don't think that happens very often. Like, he tries to let people, one thing I find is that he tries to let other people review patch series before he gets to them. Partly because there's just such a volume of code for him to be able to read it all as it comes in the first time. It'd be better if somebody comes in and says, oh, I can find your silly style issues, or I found this performance problem, or here's why you need to rethink it. And then he comes in with his, very deep knowledge and very, very particular to the Git community knowledge, and can find things that no other reviewer would find. But he tries to do that after everything else is polished and he's getting ready to merge it in. And then he has his own method of giving enough cooking time for something to make sure, like, hey, seems like review is calmed on this. I've got it in this branch. We can do some testing. We can build upon it, make sure there's nothing weird. And then it finally gets into master.
So that means that every patch via the mailing list is reviewed by the Git maintainer and that the patch will never be merged into the codebase without his approval?
Yeah, I would say that, every single commit outside of the times when he's on vacation and is appointed a sub-maintainer, if you look at the Git codebase, he is the committer. And that the idea that the committer and author are different is very much a Git-centric thing because of the way Git was designed for this mailing list sort of contribution model, where the author is the person who submitted the patch, and then the committer is the person who took that patch and created a commit. And so every single thing that gets from the mailing list into the Git repo has gone through his computer. And so at least at that sense, he has stamped it as something he's willing to take. Now, sometimes it's, here's a subsystem that I don't know very well that we're really just taking updates from stuff that's been going on elsewhere. Like Git GUI is one of those things where it lives in the Git code base, but it's kind of this second tool that isn't critical to the rest of Git working. So the Git GUI has its own maintainer and just pushes updates, and then Junio takes those. But a lot of it is, even this change over here to this one built-in could have rippling effects to the rest of Git. I've been amazed at the amount of attention he's been able to pay to all of these different changes in all these different areas.
And so, do you know what is the process of becoming a maintainer? So if I want to become an open source maintainer, what are the steps I have to take? Is an open source maintainer selected or elected? Is there a democratic vote now and then about who should be the open source maintainer of a given project? How does that work?
I know for Git in particular, it was that Git was started by Linus Torvalds, and Linus wanted to be able to do more kernel development and not have to maintain Git. And Junio was there doing lots and lots of that early development of Git and knew most of the system, and Linus just trusted him to be the maintainer. And that's just how it's been. He occasionally appoints people who are trusted members of the community to be maintainers when he wants to be on leave. And those have been people who have been on the mailing list for years, have been a trusted opinions in terms of if that person reviewed it, Junio doesn't need to review it, sort of like that quality of person. But and then there's also a board of people who are kind of, there's somewhat of a governing body, which is more about a vote process. And that's less about what commits specifically, but where does the Git community want to go? Things like protecting the Git trademark and who's paying for the git-sem.com, which has all our documentation on it. That board is democratically elected. If you wanted to become an open source maintainer, the thing you need to do is build an open source project. And, I'm technically a maintainer of several repos I put on GitHub, but, they're more of a toys that I've put. And yes, people could go contribute to them and I'd probably pay attention, but I'm not actively pursuing a community. Like, I'm trying to build a community around it. If you really want to be a maintainer of a community, it's how do you actually attract new people to your project? How do you get people to use it enough to care? And that's really tricky.
Mm-hmm. Okay. But yeah, so coming back to the maintainer and the role of a maintainer, can I imagine a maintainer similar to a founder of a company? So there is sort of a belonging of that open source project to the maintainer, because you said if you want to be a maintainer, then you have to start your own open source project. So somehow the maintainer owns the open source project. Is that something that you could take away from the maintainer?
If you wanted to make a fork of Git, you could. It's all open source. It has GPL v2 license, so you can always create a fork of Git. And in some sense, that's what we've done with Git for Windows, right? Git for Windows is a fork of Git. Johannes is the maintainer, but he's also similarly he's just trying to make sure that Git works as best as it can for Windows. If there's a fix that's actually a Git fix, it goes back into core Git. And he's also been working really hard to reduce the distance between those two forks. And so you can always create a fork. The question is, will anyone care? So in the sense that we do have free and open software in Git, but if you want to be on the version that is getting all the fixes, that's getting all of the improvements, you should move along with the community as much as possible.
Well, yeah, I definitely agree. The community, the healthy community is super important. So I'm not suggesting to take over an open source project like a pirate ship, right? So, well, I think we covered really a lot. Is there something that you want to say to round up that interview in a good way?
I guess I just want to mention that, the Git community is working really hard to be more open to new contributors. We find that it can be really difficult for especially young contributors who maybe don't have as much experience in C or have never worked with code review on mailing lists before. They've always been growing up doing pull requests as their model. That can be really daunting to people. But in the community, we've had a lot of discussions about how can we improve that environment for the new contributor. Git Gadget is one of those tools that can help us along. But we're also working on just how can we be more welcoming to new contributors? How can we pair off people with mentors? And so if you're interested in contributing to Git, please get into contact with me, or just chime in on the Git mailing list saying, hey, I'm new, I'd like to get started. The one thing to keep in mind is that we don't have a backlog to then say, here's a quick issue outside of these disparate places. But if you have something where you have not only the desire to contribute to Git, but you have a specific direction you'd like Git to go in or a specific feature you'd like to make better, we're definitely welcome to new people, and we would love to see your ideas.
Okay, yeah, that sounds good. Great. So thank you, Derrick, for being on my show. It was really lovely to talk to you and learn so much about Git and open source. Thank you so much.
Oh, thank you for having me. It's been great.
Yeah. Bye-bye.
Bye.
I hope you enjoyed another episode of the Software Engineering Unlocked podcast. Don't forget to subscribe, and I'll talk to you again in 2 weeks. Bye. Hey, if you like this show, why not help me spread the word? You can also rate it on iTunes. Thanks so much.